Hello, welcome to a video on expected value. In this video we're going to look at computing expected value and use expected value to solve word problems, and then use expected value to determine the average payoff or loss in some type of a game of chance, like at a casino or something. Alright, expected value, that is a mathematical way we use probabilities to find out what's going to happen in the long run. We use it to determine premiums on insurance policies, weigh risk versus benefits in business ventures, indicate to a player in some kind of game of chance what will happen if the game is played repeatedly. Right? Try to maybe talk your friend out of staying at the casino once he's won his money back or something. The standard way to compute expected value is to multiply each possible outcome by its probability and then add all those things together. It's kind of like a weighted average. It basically is a weighted average, where the probabilities are the weights. So let's look at one. Find the expected value for the number of girls for a family where they have 3 children. Right? So they don't have any to begin with, and we're trying to find the expected value. What they'll have after they have 3, or just 3 in general. So there is a tree diagram showing us where these probabilities are coming from. Alright, so this is the number of girls they have. That's what we're trying to find. So they could have 0 girls, 1, 2, or 3. Well, how many ways can they have 0? One way. How many ways can they have 1? 3 different ways. So they could have one girl first, the girl in the middle, or the girl last. How many ways can they have 2? Well, now you just kind of switch roles. They can have the boy last, the boy in the middle, or the boy first, and that would leave 2 girls. And then there's only one way they can have all 3 girls. So if you count them up, there's 1, 2, 3, 4, 5, 6, 7, 8. So no girls, or 0, that's 1 out of 8. 1 and 2 are both 3 out of 8 probabilities, and then 3 again was 1 out of 8. So you add all these up. Remember that all the possible outcomes have to add to 1, and you get 6, 7, 8. So they do add to 1. Now, what we're going to end up doing is multiplying these probabilities times these possible outcomes. So 0 times an eighth, 1 times 3/8, 2 times 3/8, 3 times 3/8, and then we're going to add all those products together. Right? Not this, but the products after we've multiplied. So let's just show you what happens. So 0 times an eighth, 1 times 3/8, 2 times 3/8, that ends up being 0 times 1 is 0, 1 times 3 is 3, 2 times 3 is 6, and then 3 times 1 is 3. All of that over an 8. Remember, we got common denominators, so we can put it all over 8. So you add all that up. There's 3 and 6 is 9. 9 and 3 is 12. 12 over 8 reduces to 3 halves, which is 1 1/2. So what does that mean? That means we expect, if we have 3 kids, that 1 1/2 of them are girls. Now that you may be thinking, well, that doesn't make any sense. Well, that's also an average. Like if you take, all the families in the world that have 3 kids, and you find out the gender, so maybe that's a girl, 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 all 3 of these are girls, that's a girl, no girls, girl, 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 and you add up all the number of girls that there are, and you divide by however many families or how many groups of children, groups of 3 that you had, the average number of girls in all those different groups would be 1.5. Okay, so it does mean both things. It does mean if we take a long run average over the course of all groups of 3 kids, that you would average 1 1/2 girls. But it also means it literally is expectation, what we can expect to happen if it hasn't happened yet. So if a family plans to have 3 kids, and there really is a 50-50 chance of a boy and a girl, then they can expect to have 1 1/2 of each, which again doesn't make sense. You're not going to have a half of a boy or half of a girl, but you could it's only because of the fact we're having an odd number here. We had an even number. The other interpretation of what we can expect to happen and where we get this expected part in the name, it's only not making good sense because it's odd. But they both tie together to be the same thing. The reason why we can expect 1.5 if it hasn't happened yet is because that would be the average if there were, an infinite number of 3-child groups, 3-child families, and we found the average number in all those number of girls in all those 3-child families. So it means both things, but it's perfectly fine to get decimals here because it is an average, like a long run average. All right, so let's look at one here where we actually have to do number from a table. So we're going to take these claim amounts, right, and the likelihood of getting these claim amounts. We're going to multiply these together, and then we're going to add them all up. So down here at the bottom, we've set it up. We've multiplied them all out. These are the values that we get when we multiply those out. All right, you can verify for yourself. When we add those up, we get $1,100. So that's the average cost of a claim, and that's what these insurance companies have to charge to break even. So you would expect way more than that because insurance companies aren't in business to break even. They're in business for profit. So I would expect this to be $1,500 or something like that, what they charge in the long run, or maybe even $3,000, something drastically different. But that's like a break-even point in this case, to kind of offset. Yeah, most of the time they're not going to have to pay out, but occasionally they are, and occasionally they're going to have to pay out big. So, if this were 100% of the time, then they could break even with never having to pay out anything. But because they are having these, even though they're low probabilities, these low probabilities of very big numbers, it makes that claim need to kind of balloon up higher, or the average claim amount balloon up higher. So anyway, that's what the interpretation of that is. That's what they would need to charge to break even for all the different customers that file the claims. That's what they would need to charge for their premiums. Alright, to find the expected value of a game, multiply gains or loss by each possible probability. And what we have to remember here is this is a negative number. So when you multiply a positive, because the probability is always positive or 0, but when you multiply a loss by a probability, you'll end up with a negative. And then when you multiply a gain by a probability, that'll end up with a positive. And then positive plus negative, this actually ends up being subtraction. So it brings the expected value down because of the fact that you have a negative value in there. Alright, find the expected value of betting $1 on number 20 in roulette. So the bet is a negative value. You're paying the bet out, so that's a negative number. And then if you land on that number, you're awarded this $35, and you get to keep the $1 you got back. So the two outcomes here are there is a slim chance, like a 1 in 38 chance, that you get to win $36. But then there's a 37 out of 38 chance that you lose that dollar. So that's the negative. That's where these probabilities will come from. Let's fix this a little bit if I can. So the negative meaning that we lost that dollar. We bet and we lost it. There's a 37 out of 38 chance that happens. The ball lands on the 20. There's a $35 gain, but there's only a 1 in 38 chance that happens. So when we multiply them together, this is a positive, this is a negative. We end up subtracting more than we had, and we end up with a negative amount. Negative 2 over 38, which as a decimal ends up being about negative 0.05, about a nickel. So that means we can expect to lose about a nickel every time we play this game. All right, even though, again, a nickel is not a possibility, that's again an average. Long run expected value is that at the end of the night, if you calculated how much money you won or lost and divided up by how many times you played it, it would kind of average out to be about a nickel lost every time. Alright, so expected value, notice again, multiplication and then addition. Multiplying possible outcomes times probabilities and then adding those values together. But you'll always have these, after you're done, you'll always have these interpretations. What is it that you've just found? And that's where this part comes in. This means.